Hi, everybody. Hello, everybody. Okay, well, we still wait for some people to join, and in order to start on time and finish on time, I suggest we start. Happy second week of the EU Code Week 2024. We are very happy to welcome you today on this webinar that is a part of ongoing webinar series. So, as a part of the EU Code Week, we are organizing this ongoing webinar series to support overall organization of EU Code Week events and hackathons. My name is Dea. I'm working as a project officer at All Digital, and I'm going to be your host for this webinar. And before we start, I would like to inform you that this webinar is recorded. I believe you also all saw the record sign, and the recording might be used later on for the promotion of the project. Now, to put this webinar into the broader context of the EU Code Week, I would like to share with you that the idea behind these webinars is to support the overall organization of the EU Code Week hackathons, of the EU Code Week events, but overall EU Code Week activities beyond the 2 weeks in October, so looking into EU Code Week as an overall movement. And looking into the hackathons, I propose that we start with a short video announcing the 2024 hackathons and their central theme, and then let's focus on our topic of today. So I will start sharing my screen to show you this quick video as a start. And I will do it in a second. I'm sorry for this technical thing, but it's always good to see digital skills put in practice right on spot. So let's see the video.
Welcome to the EU Code Week Hackathons 2024, where young minds from across Europe come together to solve real-world challenges. It's time to code, create, and collaborate. This year's central theme is inviting you to look into future. How can you address the challenges of the future? How will you say, "Hello, future"? Get your team, grab your ideas, and join your local hackathons from October 2024 to March 2025. Local hackathons will be organized by national hubs. Speak to your national hubs to get more information. Keep an eye on EU Code Week website and join our webinars. Join the EU-wide initiative and bring your ideas to life. Let's greet the future together.
All right, so after this exciting short promotional video, and as I said before, just to situate this webinar into the broader context, the idea is to open a space for discussion and to provide some useful resources and insights to support the organization of events, of hackathons, and to share some successful stories with invited experts in the field. Today, as you all know, we are here to talk about the impact that the artificial intelligence has on the teaching of coding. And for this, we have invited Lydia Kral to share some insights. Lydia is an education analyst, AI expert with an extensive experience in education, educational reforms, and involvement in international working groups focusing on AI and education. And today, Lydia is going to share with us some insights on how AI is impacting the teaching of coding. Lydia, thank you so much for being here today, and I pass the floor to you.
Thank you, Dea. It's nice to participate in this year Code Week. Let me start sharing my screen. Is it okay? Can you see it?
Yes, we can.
Great. Thank you. So we know that besides lots of creation that AI could do, like text, pictures, videos, AI is also capable of doing coding, so writing lines of syntax for all of us. So it could generate code, we could ask it to explain it. It could also give a feedback and exchange information with the students, saying something is working or not. It could be a pair as a partner in creation of a code, and of course it could help us to find a proper wording because we doesn't remember all the syntax of programming languages by heart. The good thing is that it could also translate to several programming languages, which is really nice asset to have nowadays. So whatever is left to the humans if AI tools could do everything. So let's focus on more complex things, more on creativity, problem solving, and of course, ethical aspects of a programming in nowadays work. So, first thing, what I would like to emphasize is difference between the coding and programming. I know that coding became a very popular buzzword, but coding originally meant writing instructions in some specific programming language, like Logo, Python, C++, C Sharp, Basic, and so on. But programming is more complex things. It talks about designing, developing those sequence. It talks about how to solve some problem, how to automate it. So when we talk about the programming, we talk about analysis of the problem, evaluating possible solutions, finding algorithms, testing algorithms, implementing it, and then translating to some programming languages, testing and debugging. I hear reference to one of the document. Uh, I was a member of the group who supported developments of a Digicomp 2.2 2 years ago when we talk about the competencies in programming area. So that document, which is additional document like annex to Digicom 2.2, suggest some competencies in the area of programming for every citizens. It says here a few examples about decomposition of tasks. So how to think about some problem and divide it in smaller parts, which then we could describe more precisely. It also talk about precision ambiguously, because if you want to have some algorithm described, you have to be very precise for computer to understand what's your intentions. Then of course writing algorithms, sorting, and of course valuing and analyze positive and negative aspects, and of course the impact and possible problems which could uh, be happening in the programming. Here I just mentioned few of those competencies which are mentioned in the document, so you could read it for your own sake if you would like. But it talks about how real life problems like the labyrinth, like the maze, if you want to think about the programming for it, you have to understand not of which kind of plants it is built. Is it built of bricks or a core? But you have to know what is the structure, how are the walls connected to each other, where is the entrance, where is the exit. Also, different strategies for problem solving. For example, if you want to order cards, will you start from a one and start to sorting and finding the smallest card, or you will divide the deck in two and then start sorting. So these are the several strategies that could help in a different problem solving. Also, the correctness, the transparency, the efficacy. So these are all characteristic of programming, which we would like to see happening. Also, with, as you mentioned, hackathons happening as part of the Code Week.
Thank you very much, Lydia. I think it's very interesting to hear that with new technologies and overall programming, we're actually looking back into the skills and competencies that are perhaps not necessarily technology oriented, like creativity, analysis. Can you please share some concrete examples of how exactly this can be done and what exactly we can do?
Yes, of course. I already prepared some examples and the pictures which could make it more understandable, explainable, for example. So when we talk about the back to the creativity, problem solving analysis, I would say we are going to back to basics or return to thinking about computational thinking, which is problem solving skills and techniques. Um, I also found out a very interesting lecture video by Miles Berry on the Code Week website, which described in more detail computational thinking and problem solving. So I'm also inviting you to check out this video. But today I will show you a few examples of a Bebras challenge. Bebras challenge, it's actually 20 years old this year, and this is international challenge which focus on a logical task, on a promotion of computational thinking, analysis of the problem, dividing into small parts, finding solution, testing solution. And it is also available for children young as first graders, so let's say 6, 7 years, when they are able to read and try to solve tasks. For example, in Croatia, last year, more than 40,000 students participate in this challenge, and it will be happening, I think, 3 weeks from now, sometimes mid-November. So feel invited to participate as well. So here are some tasks. For example, one task which talks about how to connect creature with the planet where they inhabit. These creatures have to be connected one to one. So one creature, one planet. And then there is a task about how we are defining this connection between the creature and the planet. So could we define it by colors, gray to gray, blue to blue? Could we define it by the rotation or not, by the shape, by the expression of emotion? Dea, can you guess which one is correct?
Oh,
I see
I
you
give it
have
to
a
you as an
hint.
expert.
There is always already hints in the chat. Thank you, Christina. So here the description is shape. What is interesting from the AI perspective, as this labeling and this categorization is definitely part of a data sets which build good AI tools. So here is the shape. So cube, pyramid, and so on. In description, it says why we choose this C answer for this. Why I'm saying data sets? Because data sets came into the focus, let's say 2, 3 years ago, when the boom of the AI tools start happening and people start noticing biases in the data sets. So if it doesn't have representative data set, then the conclusion based upon it could be wrong. Here is one example how students could work on finding a model that could classify some pieces of data. We just show some very simple example right now, but what I will use is, well, yours and my family name as an example this time. So recently I was in the Switzerland, and you know, in Switzerland, languages are French, German, Italian. Did I forget some French? Yeah. And people in the audience, I asked them, okay, do you remember my family name, which is Kralj? And how many of you think they could pronounce it correctly? And there was only one hand raised. So from 100 people, only one person think she could say it correctly. That means if this audience were my data set, I would have a very, very low probability, 0.01, to hear my family name said correctly. Of course, I repeated this example in Ljubljana, where almost 100% of attendees were sure how to say Kralj. This is one of the ideas how to describe data set and how the bias in this data set could be built if we doesn't think about it beforehand. One example, which may look complicated, especially if you doesn't like if, then, else sentences, true, false, logical tables. But what is interesting is that something similar to these tasks could be built. So instead of just solving this task, we could ask students to build such a machine, maybe not with the water, but maybe with little balls rolling and trying to find out good path. Maybe like the building Ruth Goldberg machine. You all seen those videos where the little ball is going down the stairs, then there is some toboggan, there is some squares, there's jumping and end up in the cup or not end up in the cup or so on. So here, for example, we have to decide which of the pipes should be open or should be closed, so the water ends up to the apple trees, not out. For example, the clearest answer would be that a part should be closed, because if a part is open, water is going down and will miss the tree. Will somebody in the chat help us finding the good answer? Okay, I don't see any good answer, so I will just proceed with showing the good answer. Oops, sorry. So it says A have to be closed. So we decide that already with my help. But then B should be open, C should be closed, and D should be closed. And then water from B will go to one dish to another and then to the trees. Here is describe informatics background saying this is abstract model, this is simplified image solution. So this is the way we work with the students, with the real life examples, but which are simplified. So in a smaller steps we divide the problem and are looking towards finding the solution. Also, this doesn't have to be, as I mentioned, only abstract tasks. We could work with the real dishes, with real water or little balls, and trying to test and trying to create some of similar experiment. Here is one little more complex things. It's talk about how to build dams so the water goes in a specific direction. This is for you just the illustration how Beber's task doesn't have to be very simple, like the example with the planet and creatures. It could be more complex. But for example, this, although the task is given with a picture, actually talks about kind of complex algorithm, Dijkstra algorithm, which talks about finding the proper way and how to connect the dots and spots. Well, this is brand new photo. So something I've seen last week in Finland, in the University of Helsinki, University for Future Teachers. This was part of their Playful Learning Lab. Their Playful Learning Lab is also meant to teach about the algorithms. I know you see only wooden bricks and pieces, but this is actually intended to build a machine which could lead little balls to different parts. So you start from the brown and red part on the left picture, and you have to lead it towards the end. So students are given a basket full of wooden pieces and they have to create their solution. Try and error, combine, discuss. And may I ask you, audience, what do you think for how old students are this task prepared here? So the question actually is, when do you think we could start teaching computational thinking with the students? Let's see, maybe somebody will get involved. There, what do you think? Oh,
Well,
Marisa said
the answer
ace.
that is there is what I wanted to say, actually.
Absolutely. And they say the kindergarten. Yes, they actually tried this and playing with this with the kindergarten kids. But I'm sure that all of us adults will enjoy playing with such a bricks and models to create algorithms. Thank you all for your support and answers. One more colorful idea for unplugged coding, unplugged algorithms, and finding a solution to the problem. It is also originate from the Code Week website. It's one of the example for inclusion, and it's using a egg carton and some, well, not real eggs, just not to break them all, but some bricks, some arrows, and think about the obstacles on the way and how to lead the little creature, the little figure, to collect as many rewards as possible during the way. So each of these tasks, I think it should be seen at least from a two perspectives. One, here is the problem, please try to find a solution, discuss, and so on. And another, okay, here is a blank screen, here is a blank egg board, try to create the problem and then work towards the solution. Also, this slide very colorfully describes my attitudes towards the teaching and learning, which says any technology that help us achieve learning outcomes, that help us in process of learning, supporting our students is good. Sometimes it's a scissors, it's a glue, it's a paper, sometimes it's a computer, sometimes it's a robot, sometimes some AI tools, but all of those could help us achieving learning outcomes and also in the process of playing, having fun, and learning. Well, this is me playing in the airport in Munich 2 nights ago. Of course, I was bored. I had to wait a few hours for my next flight. But the thing I want to show you here is how instructions look like. So for this Lego example, you have a specific visual instruction step by step how to create the flowers. And I could follow it. I think it's 5+ the age of this constructions. And of course, I have fun making some photos, but you could also do it reverse engineering. Okay, here is the flower we created. How to get from the flowers back to the instructions? Are there other ways to construct these flowers? How we could combine, how we could recombine those parts? Maybe from this lovely sunflower, we could create some other kind of flower. Maybe we could combine all those three and create something new. So the all of this thinking process, how to create steps, how to describe it very well, how to find different solutions, have also be supported with discussions, with debriefing. So we usually doesn't have enough time to talk. We forget we are running towards finding the solution, finding the end perfect solution and rushing, and forget to take time to discuss, to hear another idea, to listen about, to try some other approach, discuss. So this activities which happens as a part of a problem solving process is very precious. So take your time, talk to your colleagues, talk to your students, discuss, doesn't always lead the way, more like, okay, could we solve it this way? Why you think this is a good way? Have you noticed some positive sides? Have you noticed some negative sides, some errors? What happened in the meantime? So I hope you will enjoy building. Doesn't mind is a wooden bricks or some flowers. And even further on, also example from Finland. This one talks about bird song. So kids were given a poem to read, to sing, to talk, to mention it aloud. But then they're talking about different bird songs. So here you could also involve data sets. Different bird song, different species, different sort of birds. We are again back to the data set, data categorization. But here also they connect dancing with the bird song. So involving some physical activity is also good for memorizing things. So, memorizing some algorithms towards the solution. So, how did you analyze those bird songs? Where could you find the information? All this could be combined as a part of a computational thinking and informatics. So, here is the example of bird songs and a bird dance. And here is an example of a flying fish. And this was very hands-on activities, trying to put plastic fish on a tree and see does it fly. If it's not flying, why is not flying? So, which creatures, which object could fly? Why are they flying? Why could they fly? Do they stop the motors when they're high enough and start to flow? So, discussing it, hearing different ideas, testing, erroring, never forget to play and have fun with such activities. So I'm I hope that you and your audience are happy with these playful ideas, how to develop some programming competencies while also having fun.
Thank you very much for sharing, Lydia. I think these are all very interesting and very concrete examples. Thank you also, especially for explaining data sets in terms that are easy to understand and easy to feel related to. Especially also then thinking about bias and thinking about data sets and bias in easy terms. I think this is going to be very useful for hackathon organizers, for hackathon participants, but also overall for participants in the EU Code Week. Looking now into the hackathons and overall organization of hackathons for organizers and participants, is there anything else you would like to share with our participants, especially looking into the use of artificial intelligence?
Well, thank you for asking this question. Very good question. And especially me, who is involved in ethical aspects of different AI tools in education. And this is the question I always like to answer. So, I prepare again just a few slides to illustrate those ideas. Uh, 2 years ago, well, exactly 2 years ago, a European Commission published ethical guidelines on the use of artificial intelligence and data in teaching and learning. I was happy to be part of the team who created those guidelines, and I'm also happy that it survived the test of time and are still relevant and very useful. So I would like that as a part of the hackathons, all participants, either from a student or from a mentor level or from a judge level, also think about ethics by design. So how are we going to raise future programmers? What are ethical aspects we would like that our students have built in their mindset from the early age? You all agreed with me that we could start in the kindergarten. Okay, let's ethics start in the kindergarten as well. So thinking about good use of those bricks when we are programming. Here are some areas which these ethical guidelines describe in the context of a digicomp edu. So describing positive, negative aspects, models of learning. So having a humanity in the focus, supporting different needs of a student, different needs of the citizens. Also use teaching and supporting development in the area of data and AI governance. I hope all of this will be reflected somehow in the hackathons as well. What I also want to mention, these are four areas that are described in that ethical guideline. So whenever you work in the programs, please think about human agency. Where is the human in that process? Could human who will be using that tool, that applications you are creating, have informed choice? Could they interfere and work with the tool? Or please have in mind no harm principle. Also, fairness. Will that thing that you are developing will be will be fairly available and useful for all the citizens, or it is just for a minor group of the users? So think about inclusion, think about non-discrimination, but also think about the human dignity, about our well-being, meaningful interactions, and also, as the last one say, justified choice. So transparency, participation, and ability to provide explanations, which is also leads us towards transparency and explainability. So don't build big black boxes. Think about the process. That's why I'm saying debriefing, discussing, commenting is very important. Take your time to discuss with the peers, discuss with the mentors. What are you building? Why are you building it? What is the aim? How could you, the process, the solution, make more fair, make more good for the humanity, and so on. Besides ethical guidelines, one of the very important document which was approved and accepted this summer is, of course, AI Act. AI Act, among other things, mention high-risk AI systems. I know that you are not going to build high-risk AI systems as a part of the hackathons, but I would like that all of you read Article 7 of the AI Act and think about those criteria. So the criteria for transparency, explainability of AI system, how are they impacting, how are they influencing humanity, and why, while you are creating your solution, think also about the answers to those criteria. Could you answer them? Could you find appropriate solution that is positive, that could be answered positively to those questions? So thinking about what is intended the purpose, what and which data is collected, how are they used, how are they processed, how are they protect. Is there an option for human to override the decision? So if you're making some tool which, for example, recommend some learning resources, is there a possibility to um, override that recommendation? So maybe somebody will like to recommendation app, system to work differently, or whatever solution you are working for. So where's the human in that process? Think about, will it cause harm to health and safety? Does it have impact on fundamental rights? I think it would be good if you prepare with your hackathon such an explanation. So you are backing up your solution, your ideas with really, really good background, saying, yes, we are protecting human rights, child rights this way. Also, how this solution will affect multiple persons. You know about the strong bias in the AI tools. We don't want to see such a strong bias mirrored in the new developments. For example, it's clear that AI tools for designing the pictures, if you give them word nurse, you will get a female figure. If you gave them word doctor, you will get a male figure. I hope your solution will be better than that. And also some other biases already built in, which we should all be aware. Regarding those criteria, Article 7 also mention how much people depend on the outcome of the system. One of the examples mentioned in AI Act are very high risk, for example, maturity exams, which are assessed by some AI tool. So this is a very high impact because if AI tool give a wrong grade, wrong assessment, young person will not be able to attend university they would like. So this is something, of course, you are not building that, but having in mind how much impact this outcome will produce on the human, and if there is a possibility to opt out from that system. I'm talking about that because when we talk about the education, students usually doesn't have a right to opt out of some exams or a testing or assessment. Of course, there is also a question of imbalance of power. So when the government towards the citizens or teacher students, then how easily it is to fix those errors. So is it possible to reverse the outcome, to change it? And of course, the magnitude and likelihood of benefit of deployment. I know that these criteria sounds quite complicated because they are, but if we are teaching computational thinking, we should also be teaching ethics. And I know that in some countries, this part is also part of um, curriculums for younger students as well. One of my favorite part of AI Act is right to explanation of individual decision making. So if you're building tool which make some kind of decision, you need to be able to describe that decision. So how that happened. You remember the example with the water pipes and the dishes. Could we describe and could we explain decisions made in that system? If I keep A open, water will flow down. Yes. If I keep A closed, water will flow that way. So this is a simple example and simple explanation. Of course, in your solution, the hackathon, that will be more complex, but please don't forget that every human has a right to obtain from deployer, so whoever is creator of program of the algorithm of tech solution, meaningful explanation of the role of the AI system in decision-making procedure and main elements of decision taken. So imperative to have a human in the loop in all application of AI system in education. I would say that these 3 slides, although referring strictly to AI Act, actually means about any kind of technology. So whenever you are using technology, please have those criteria, have those recommendations in mind, because then you will have a clear conscience saying, yes, I've done something which works good, but it is also good for humanity and people today. So with that, I am concluding my talking about what we should do, how we should do, and how actually AI impact, I would say, is helping us getting back to the basic, getting back to the things we are good: creativity, problem solving, discussing, debriefing, tinkering, trying. And this is a lovely design created by Microsoft Designer because I'm very bad in drawing. Thank you.
Thank you very much, Lydia, and thanks a lot for bringing up important points linked with the AI Act. Also bringing the focus on ethics, on inclusion, well-being, transparency. I also really like the message of discussion, debriefing, and commenting. I think this is something we can all also take on from this webinar. Just in case somebody didn't see in the chat, all the documents and activities are also linked in the chat, so you can easily access all of them, all the documents, all the activities. And maybe to conclude our today's webinar and to wrap up this discussion, why would you say it's still important to learn how to code, how to program, even with all the recent AI developments and the use of AI overall?
Um, well, I would say with all those tools in our hands, we still need to have conceptual understanding, code sensing. So understanding what is happening under the hood, as they say. Um, so one layer is creation of such a tools. Another layer is critically evaluating and assessing those tools. The more we know about programming, computational thinking, the more skills, competencies we have to critically analyze those things when we are using them. So I'm expecting that in a future years, well, already starting, um, we will more and more support students to become critical consumers and responsible creators of different technology, not just AI technology. Generative AI is helping with the writing codes, it's helping with the translating code, but if you doesn't know how some algorithm works, how data sets are created, then you can't access this result which you get from the AI tool. You can't trust all the results to be good, to be useful. Maybe they are working, but they are not ethically sound. Maybe they are breaking some laws. Also, European Commission in recent Council recommendation on improving the provision of digital skills in education and training is supporting high quality education in informatics in school. So I make these all competencies I mentioned in programming, computational thinking as a part of informatics in school and available to all the students, not just those who are intend to specialize in programming, because we all know that problem solving skills, analyzing, tinkering, trying to find a solution, explaining your solution, explaining the steps you take, it's good for any job you do. I would say, for example, nowadays I'm doing analysis of different textual documents, but my problem solving skills, my analytical skills are actually built through programming, are built through computational thinking. So it comes very handy in different areas of your life, maybe this year, maybe in 10, maybe in 50 years. So please check out also the council recommendation and see how you could use it as a support, as a tool for your everyday teaching. I would say that our role, well, from adults, but also from a perspective of the students, would be to demystify AI, encourage critical mindsets towards the limitations, benefits, but also impact on society from the AI tools. I would say if we compare the mindset from a year ago or more year and a half ago when the boom of generative AI happened, I think we are getting to more reasonable level, for example. So we are thinking more critically. We doesn't accept all of the results of AI tools which are coming out. We are assessing results from a different tools, comparing, seeing what is usable, what is not. We are also looking for the references. If some tools are giving us some summary of something, okay, from where those facts, from where those words are coming from. So we are not taking everything as granted as we used at the beginning of a generative AI. Also, I think it would be good that we support students development in creativity area, so creations. I showed a lots of playful examples, so give students, give us time to play, because this is important part of discovering and exploring. Also, don't rush towards the final result. Let's try to stop, take a time to think about something, analyze different paths towards some solution, discuss possibilities. I know that when we are solving some typical mathematical tasks, as an example, we are just rushing towards the final result, which is x equals 5, for example. But then we forget to think about, oh, which strategy have you used to get there? Are there other possible solutions? So discussions and trying are very, very important. Ethics by design. So ethic is very important, and it is very complicated if you want to apply ethics whitewashing at the end of the product cycle. So think about that from the beginning, how you could back up the things you are creating. How could you back up the process of creating, the data you use, the algorithms you create? Describe it. So don't make transparency and explainability as some complicated word, but if you think about it from the beginning, it will be reasonable and it will be very useful for all. So from the developers and also from the users' perspective and position. Also, I mentioned at the beginning, nowadays definitely focuses much more on a programming than to coding. So it's not everything in the syntax. I remember my years when learning programming, we should remember all the syntax, and that was complicated. It's not easy to remember all the stuff. Nowadays, of course, you doesn't have to remember the syntax of any programming language, but because any computer tool will help you. It doesn't have to be AI tool, but understanding the logic of some algorithm, some procedure, some strategy is much more important. And of course, that thinking process could be applied in any of the programming language. Of course, there are differences in the use of programming languages, but when you know the logic, that it's much easier. Um, of course, when you mention hackathons, it's all those hours of work that will be embedded in the creation process. But please take time for debriefing, and please take time for celebrations, because you created something. And we are very happy to see what you achieved, how your path goes on, and all wonderful solutions. And one of the words I heard a long time ago is that fail is just the first attempt in learning. So I would say I wish all of you a lot of learning in this process, and be smart and ethical all the way.
Thank you very much, and thanks for finishing on this very, very easy to remember note as well. So adding to the discussion, the briefing, commenting, and of course, celebration. I think it's also very important that you mentioned not running away from the artificial intelligence. I mean, I think we all agree that it is here to stay, but rather on focusing on demystifying, encouraging critical minds, and the impact that the AI can and is going to have on the society. So thank you very much, Lydia, for sharing. Thank you all for joining. The recording of this webinar will soon also be available on the EU Code Week website in case you would like to rewatch it again, or in case you would like to share it with some of the participants that were perhaps not able to join us today. In the meantime, in the chat, I also shared a link for our second webinar, which is going to take place this Thursday. And we're going to be looking into a specific experience when it comes to organization of the hackathon. So in case you're interested, please feel free to join us, and we would be very happy to see you again. So thank you all. Thank you, Lydia, and see you soon. Bye-bye.
Thank you, everybody, for nice comments in chat. Unfortunately, I can't like it, but thank you very much, and looking forward to seeing you someplace else. Goodbye. Thank you.
Bye.